Short presentation on electrical power, voltage and current, the equation, some questions and answers at the end. If you want some more resources, you'll find them at my shop on the Times Ed. And don't forget to press subscribe and like below. Into the equations. Voltage is in joules per coulomb and the current is coulombs per second. Power is joules per second. Now you can use that to give the equation for power. So if you want to pause here and have a quick go at working out what the equation for power is, please pause. For those who haven't paused, or if you've pressed play again, power is actually voltage times current. And let's just show how you could have done it. Voltage is joules per coulomb and current is coulombs per second. Well, the coulombs cancel to give you joules per second, which is the unit for power. So there's the equation that you need to remember. Power equals voltage times current. But we also know another equation, and this one is from Ohm's law. And it's V equals I times R. Now V equals I times R means I can replace the V in the equation. So I start the power equation, V equals I times R. This V is going to get replaced, and it's going to get replaced with I times R. So I times R times I, which gives us, when we expand those brackets, I squared times R for the power. Now we can also rearrange Ohm's law to give us I equals V over R. And I can replace this in the equation. So let's write the equation out again. Power equals V times I. Well, now I'm going to replace the I term with V over R. So I get power equals V times V over R, which equals V squared over R, or V squared divided by R. Now, you don't need to remember all these equations. All you need to remember is Ohm's law and the power equation. If you remember Ohm's law, you can work out the other term and just plug it in. Or you can then rearrange it and use the power term the other way. It's up to you how you do it, but those are the two equations you need to remember. This one and this one. Because if you can remember those two, you can derive the others if you need them. As well as that, efficiency is quite often used in these equations as well. And efficiency is the useful energy output divided by the total energy input. Now that will give you a fraction, and if you multiply that fraction by 100, you'll get a percentage. Okay, so that's how you use the efficiency equation. Okay, now on with some questions. If you want to pause it here and have a go at them, that's the best way of doing this or going through this video for your revision. If you want to just watch me answer the questions, by all means, carry on. An LED TV has an efficiency rating of 20%. It draws 1.5 amps from the main supply of 230 volts. Okay, just looking at those units, those are all the units that I need for my equations. Voltage, or the potential difference in volts, and we've got the current in amps. Calculate the electrical energy supplied per second. Power equals the voltage times the current, which equals 230 times 1.5. That equals 299 watts, or joules per second. 1 watt equals 1 joule per second. And I should have said earlier, but we need potential difference in volts and current in amps for the equation to work to give us joules per second. Now that's not correct yet because this is two significant figures and that's two significant figures. So to get it correct, it should be 300 watts to two significant figures. Calculate the useful power output of the TV. Useful. It's 20% of the total. 20% as a fraction is 0.2. Let's write the efficiency equation though. Equals useful over the total. So we get 0.2, which is the efficiency, because I've not multiplied by 100, equals the useful divided by 300. So the useful equals 0.2 times 300, and that equals 60 joules per second, or 60 watts. How much energy is wasted by the TV in 0.5 minutes? 0.5 minutes is there to trip you up. Some people will just put in 0.5 when they multiply it and they won't get the right answer. Now, the wasted energy, we're using the law of conservation of energy now, because the energy going in must equal the total energy coming out. So the total energy out must be 300. If 60 joules is useful, that leaves us with 240, which is wasted. So from the law of conservation of energy, conservation of energy, total input equals total output. So total input, 300, equals useful plus wasted. So the wasted equals 300 minus 60, which equals 240 joules per second. Now we need to do this 0.5 minutes in 30 seconds. It's 240 times 30, which equals 7,200 joules. Okay, so that's the answer for the last part there. Last question. A bulb is used in a lab circuit rated at 3 ohms and 0.25 amps. What voltage is applied and what is the total power output of the lamp? Okay, so the power output, we can use one of the other equations that we did just earlier. Power equals I squared times R. So if we put those in, we get 0.25 squared times 3. So we get the power output as 0.1875 watts, and you should be changing that already in your head to 0.19 watts, or joules per second if you like, and that's to 2 significant figures. Now we need to know what the voltage is as well. So V equals I times R. So V equals 3 times 0.25. So it's a quarter of 3 for your answer for that. And the answer is in ohms. So it's 0.75 ohms. Okay, I hope you found this video useful, and don't forget to press like and subscribe. Thank you.